I think we'll be using multi-agents in like 10 years. Yeah.
But the world is full of software that is totally uninterpretable, even to the engineers that work on it. Nobody needs to understand why Amazon is doing what it's doing.
Welcome to episode 7 of The Forward Pass. This is our monthly show where we AI entrepreneurs bring you the latest insights from the cutting edge of the world's fastest moving industry. We're all building products at the frontier, so we're going to be sharing our real challenges and technical insights. If you're building with LLMs and you want to sharpen your craft, this is the show for you. So let's dive in. So we have a couple of great topics this month. We're going to talk about LLM agent systems and how to kind of optimize those. We're going to talk about how in production it becomes possible to be confident that your model updates are actually working just because of the nature of the spiky intelligence there. We're going to be talking about some surprising updates in kind of our timelines around how fast the field is moving, and probably a couple other topics as well. So, yeah, Chris, do you want to kick us off with this topic around LLM agent systems and get us started?
Yeah. I mean, I was definitely like curious of everyone in this group's experience with kind of like building an agent that is based on a LLM, has access to like a whole variety of tools, and is kind of meant. I think like currently the one that I'm working on is kind of like used in a chat, interface. But like the kind of like question and things that we're using like an eval framework for is essentially like comparing uh, a very large like system prompt with all types of instructions on like when to use tools, how to format things, guidelines, all of these things versus a multi-agent system that kind of like splits that up into say 4 or 5 different like agent types that have their own very specific system prompt. um and yeah, just kind of like curious. I mean, I see like similar results, obviously, the in terms of like quality of responses, but obviously like the multi-agent system has uh higher latency. It kind of has a benefit of being able to have like, say, smaller, cheaper models on certain steps of that may work well with those types of models. So it you can kind of gain speed there sometimes. um but yeah, I guess I just kind of like wanted to throw this out into the group of like what people have seen in practice, and do they tend to avoid like really large system prompts versus breaking that down, kind of a thing.
Yeah, I think there can be value in both, but I would say, can I ask a couple questions about maybe just focus on the particulars instead of trying to over abstract it, because it does feel like more of an engineering question that's so specific. Do you feel like you're able to parallelize any of the tasks, which could potentially mean that the latency actually could even go down if you're able to do that enough, but at least not go up by nearly as much?
Yeah, certainly. I think there's some things that certainly like can be parallelized, like pulling a whole kind of like historical data set from a database, while also using other tools and things like that in parallel. uh,
Okay.
but they also kind of like have this kind of like supervisor orchestrator type of agent that waits for all of those to kind of like return, and then pieces things together as like final output. um and yeah, so it's I think like there's still, you're waiting on your like slowest piece there, you know.
Yeah.
So
Yeah.
yeah.
And then do you feel like the problem is naturally composable? Meaning like it really breaks down well where you can give it these specific tasks? Because I would say that's more of an art than a science to know the answer to that. But I would say like if that feels like the case, then it's always going to be better to have a simpler set of tasks than a more complex one. I mean, it's just like humans too. Like if you give us a very complex task, we'll be less likely to do well versus a series of simpler things. Yeah.
Yeah. Yeah, no, I think that's like as, software engineers, just like engineering in general, you're just so used to breaking things down into smaller steps and like very clear instructions and kind of like building up, systems as combos of these like smaller, simpler pieces. And so I think like definitely engineers tend to gravitate toward that as like the preferred um, solution, but um, it's just kind of like, and it certainly works. I think it has its benefits, but in this world of like very long context, I guess for LLMs, is just kind of like curious if people see um, like context, like I guess just um, a language model like forgetting something or not really
Yes.
paying attention to it, and um, I feel like I've certainly seen that anecdotally in like you know coding threads and cursor of like just really long things, and it's kind of uh, hitting a wall, and you just start a new conversation, and that kind of sometimes helps. So
Yeah.
I don't kind of
Yeah.
curious if that's the same, with some of this as well. But
I'll let others chime in next. Obviously, I want to make it a conversation. But last thing I'll say is I think I would always have a default to break it down. It's just almost for sure going to work better in my experience. That's the architecture we use for our AI therapist for sure. And I think there's another angle too, which is not just like simpler tasks, and then you can have the synthesis layer, but it's also that like it's just different angles on the problem and have it thinking and doing reasoning and going deep on that. Like, for example, for us, like an example would be like analyzing the person's like deeper motivations right now in the conversation. Like that is a very specific task that is pretty different from like analyzing what the therapist should focus on next. Like those two things are related. And if you ask it to try to do, they're related, but they're distinct. If you ask it to try to do both at the same time, it's just going to get confused. It's going to muddy them up. It's going to like put them together, and you're not going to have this clean distinction. So I would say like there's a reason the multi-agent systems are so popular. Like they do perform much better in my experience. That said, I mean, I'm only focusing on like a very specific set of tasks around like kind of mental health, but I think they generally perform quite a bit better. Latency and cost are the two downsides.
Yeah, I'll jump in with sort of our angle. I think when you talk about like is it overall better, I think there's kind of two major dimensions, which is like accuracy, like is it doing the thing it's supposed to be doing? But another one is consistency, where you don't want, one day it says this, the other day it says that, and has basically the same input. For some cases, that's like we work in regulatory and compliance, and so that's yeah, you very much want consistency. But even for a consumer, right? Like you don't want it to like, oh, I tried this prompt, it worked really well. I tried it again, and it just doesn't work anymore. Um, so I think that's like if you try to go for both of those, the simpler tasks is much easier to try to like get both, a little bit of both. Versus like if you optimize for accuracy, then okay, like in this particular case, like you're basically going to overfit whatever your whatever your
Mm,
integration test is, and then your users
mm.
will get perhaps a less consistent experience.
So you almost see those two in tension, Michael? There's like a trade-off there.
Yeah, but it's not like a direct. I mean, it's almost like, yeah, it's like you can optimize for one or the other, or you can like kind of go split the difference a little bit, but it's hard to get. Like if it's completely accurate, like like how do you not overfit your examples, right? Like when it's running in production, users are notoriously unpredictable in what they send, so like you have to, you know, like if your task is really complex, it's gonna have weird corners, right? Where users are gonna get stuck. If it's simpler, I think it's like it's more likely they're within the bounds of like what it's supposed to do.
I want to harp on to your point, Tyler, about parallelization. I think in my explorations with multi-agents, it does largely come down to what can be parallelized. And the answer to that question is often far from obvious. And I think it actually takes you have to kind of break down the problem in different ways. And the way that we do, as you were talking about, Chris, is kind of like, well, you plan out some solution first. If you can plan out a solution and you can find something that can be done in parallel, then great. And you might approach it in a different way. So, like, for example, if you're looking into GLP-1 drugs or biotech firms or something like that, you ask some question about like what's going on with GLP-1 drugs, or like what's going on with these phase 3 trials, or what are these firms doing. You could kind of do a deep research style where you just ask a question, do some web searches, consult a database, then ask another question, then ask another question. And this kind of like depth first search might be optimal. And then you don't need a multi-agent thing. You just need to just run it in a loop and let it go until it runs out of budget or floods the context window or whatever. But if you organize it to have a parallelizable step, so for example, let me go read what like 50 different companies have said on this, or let me pick like 50 different analysts and see what they have said on this, or let me read 50 different papers on this. If you design your solution to the problem to do that, then you definitely want a multi-agent system, because once you get to that step, you want to split it out, have them all go. And yeah, as you said, Tyler, it could be even faster in the sense that by going broad, you might find something really decisive really quickly. And maybe you can even cancel all of the other threads, have your orchestrator say, oh, this looks really promising. And now you've got this answer. Whereas if you used a single agent, it might just have to go and go and go and go and go and go and to eventually find that same thing. So it depends on what the problem is and what the solution is. Future Search does like a lot of research and forecasting stuff. Like all of our problems are hard. But I had this in Claude Code just yesterday too. I was looking, hey, what's a good way for me to build an onboarding flow for this app? And the first stage was, well, what are good UI frameworks for onboarding flows that work with my whatever tech stack, Next.js, React, or whatever? And it finds like a bunch of them. And so a really obvious thing to do is like, well, research them all in parallel. Like, here's my requirements. Like, go to all of these libraries and see, like, do they support light mode and dark mode? Or like, what's the integration with this thing? Do they do single page applications or whatever it is that I care about? If I did it single agent, it would just take way longer. So really the multi-agent is actually just a much faster way to get a more reliable answer. And yet to your point, Michael, I'm not sure what the trade-off is between accuracy and like consistency. In theory, if that structure is looking at all of the options, it should give me the same answer every time. In practice, though, it's churning through so many tokens. I mean, God knows what it's actually going to come up with. Like this time it's going to be, oh, this UI library is great. I found this, piece by this person building something that's very similar to what you're building. And it works great for them. The next time that sub-agent doesn't find that article, it comes to a totally different conclusion. You could make the case that the multi-agent would be more consistent, but it could be less consistent. I really have no idea what the relationship would be between like how much you're orchestrating it versus the consistency when you ask the same question the next day.
Yeah, I probably overuse the human analogies, but I would say that like when you think about like human personality, there's like the big five. And like accuracy is probably more correlated with like openness, meaning like, do they consider a lot of different things and then come to a conclusion, basically where they like open-minded? And then consistency is more like conscientiousness, which is like, did they always do what they were supposed to do and kind of follow instructions and like do their homework and things like that? And those two things in humans are completely uncorrelated. Like they're just literally, the correlation is zero between those two personality dimensions, like by definition. So I would assume that I would be surprised if there was some deep reason why consistency and accuracy were inversely correlated. But that's a pretty weak argument, to be honest, with like the personality metaphor. But it also vibes with my experience. I haven't found that multi-agent systems are less consistent.
Yeah, I think what Dan
Saying a
said
little bit
about
more about flooding the context window. Oh, sorry, Michael. So
Michael wanted to defend himself. We both just
no, I just want to
told him
pile on here. Here's another reason why I disagree with you. No, there's something about the context engineering, which, you know, I see in the production systems that I built, and we've talked about context engineering on the forward pass before, and this is something I think everyone's paying attention to. But in Claude Code, I noticed that there's, you know, Claude Code has planning mode and non-planning mode, and I think other like command line agents have similar things. I've noticed that I pre-register ahead of time when I start a session with it, whether this is something sufficiently complicated where I need to have a plan. Generally, when I don't have a plan, I still have it tell me, like, okay, what exactly are you going to do before I authorize it to go? But it's not really a plan in the sense that it doesn't have like pseudocode implementation details. It doesn't have a checklist. It doesn't have like a testing regime. But sometimes when I start, I know a thing is going to be complicated enough that I'm going to need to write notes simply because I know eventually I'm going to run out of context. Like I'm just going to be doing more research, reading more code, looking at more examples, trying more things, and eventually it's going to get confused and flutter out. And at that point, I just know ahead of time, I want to have a document that is tracking this. And so from the original query, I'm like, go make me a document to track all of this stuff. And when I do it, often I'll have, you know, a 500-page reading file, just like, here's the problem, here's the plan, here's what I've learned, here's what I've tried, here's the proposed solutions, blah, blah, blah. And then I run out of context, start over, start with the document again, like refine it, sometimes over and over and over again. And eventually I have something that makes sense. And then I say, go implement it. If you know ahead of time that you're going to have a document, then again, like kind of like a human, like if you're taking notes while you go, you can do something of kind of arbitrary complexity because it's a project and you're just working on it. You're never going to forget or lose track of things because you're taking notes and you're organizing those notes as you go. It's like a research project. You can go for months. You're not going to remember everything that you read, but you're taking notes, you're doing it formally, things will be fine. In that sense, I think the context engineering, like it's work, but it's never going to defeat you. Like you can always put an entire research plan into the context window, like a 1 million context window. Can put like as long of a research plan as you want, like an implementation plan for Claude Code. It's always going to work. And so in that sense, I say lay on the multi-agents, like do as much of the research and iterate, like try different approaches in parallel. As long as you're writing down and organizing your results and reflecting on what you have, you're never going to run out of like real context in the way that a human engineer would never be like, well, I've been on this software project for a month. I can no longer remember what I was doing. Oh, well, I guess I can't finish this project, right? Like as long as you organize things well enough, you can always pick it up where you left off.
Yeah, I think that's a good analogy too of like that context, that super long context is like this, you know, fast way to like get someone ramped up on it, you know, just instantly basically for a language model. And yeah, I've found it like interesting that like Cursor and there's this other one, Kiro, that's like I think tied to AWS is like one of their products, but they kind of like really push the any kind of like coding task that you're trying to give it, you have to come up with like a plan, and it creates, you know, a spec and tasks and just like basically those documents like you were saying, just to do anything so you have it. But it's, yeah, I've found that helpful too in the coding.
Yeah, I think multi-agent is a huge theme. Like, I think we'll be using multi-agents in like 10 years. The reason I think that, and I wouldn't say that about most things in this space, even like the transformer architecture, I bet will get replaced. But I think it's just like the idea that breaking down a problem into different parts and then having different, like an orchestrator layer that maybe chooses between them, but like then there's specific tasks. Like that's just a fundamental thing that any complex problem is going to work that way. I think that I would make a distinction between multi-agent systems that are relatively rigid, meaning you like already, the human author, broke down the problem into like, these are the 7 things we have to do, and we're going to do these 4 in parallel, and then these 3 in series, or like, and we know exactly what they are. We know what the prompts are, versus where there's actually a system that is much more in control, and it determines almost like tool calls among the multi-agents, and it then orchestrates and says like, I'm going to invoke these 3 right now, and those will run in parallel. When they come back, then I will decide what to do next, and maybe it'll be these other 4 agents, and maybe I have like a basket of like 30 agents that I can pick from, and it could end up looping. So it sounds like what you're saying, Daniel, is that you're describing more of the latter, where it's like a more of an open-ended set of things that the system can end up doing, and the eventual compute graph between them could be pretty arbitrarily complex, versus like the compute graph is fixed, but you just broke down the problem into different parts.
Yeah, I think for coding, this effectively already works. I mean, obviously, there's tricky things you can do with your coding agents to enable via MCP servers for it to like do this part by sending something to something running in the cloud, which will respond with like a commit, and then I'll like kind of go on in that way. I don't know. I'm not sure if you guys have tried this. I don't know anybody who's actually got this working, but there's a much more kind of casual sub agent thing. And again, I mostly see it when Claude is using the web. It's like when it's reading documentation, for example, it'll queue up a bunch of fetches of pages to look at various libraries and look at various solutions, all in parallel. And it's just a very natural thing to do in parallel because it's web research. It's like a human opening a bunch of tabs, like reading things. Like it's just a very natural thing to do. So like that kind of thing, yeah, it's open-ended, Tyler. You don't know ahead of time how many agents you're going to use for what. You've got kind of your master agent orchestrator that is paying attention and knowing how to use a budget and when to like not get confused and stuff. And then there's the much more advanced mode, which is I effectively have a whole team of software engineers working on this, where every individual software engineer is like very good, and the person in the middle is like a software engineering manager. I mean, in theory, this should be possible. I just don't know anybody who's actually gotten this working. Like you do still get to the point where the orchestrator, the software and engineering manager is just literally not smart enough to like correctly assign people to tasks and look at their results and then figure out what to do next. The LLMs are just not at like expert human level. And like a kind of a mediocre human's not going to be good at that either. Like it is just very difficult to orchestrate a bunch of human engineers going off and doing things. But why not, right? I mean, we've come this far. Like it seems like it's only going to be a matter of time where it will seem like an orchestration of human level software engineering agents that are all going on dividing and conquering, doing things that are measured in the size of whole commits or PRs, rather than something that is like, okay, I implemented this one method of this one function. It seems inevitable, really. I guess the main thing for me as a builder is like, when should I even try this? Because I have no expectations that it would work right now, or just be more hassle than it's worth. Or maybe for a particular easy thing, maybe something that's entirely on the front end, like if it doesn't have an API layer, if it doesn't have a database, maybe if I'm just building like a web app or an iOS app, that entirely could be done in that type of way. But when
I found that these.
Yeah.
Oh, I'm sorry to interrupt you. I found that they're better at back end by far than front
Oh,
end.
really? Well, say more about that.
They're bad at front end. They're bad at, well, I mean, there's certain parts of front end that's like the integration layer with the API, or like persistence in like a local SQLite database or something. It's great. When you're trying to be like, make this look good, it's horrendous. No matter how good your prompt is, no matter if you include like really nice screenshots, you can include the Figma context. There's like plugins with like Figma that doesn't matter. Like they fucking, sorry to swear. I forgot if we allow swearing on this, but I don't care. I'm doing it. They fucking suck at making interfaces look good. They just are really bad at it.
Well,
yeah,
I think they can write unit tests for themselves, but they can't really do visual inspection the way a human would.
Exactly.
So I think that's what it comes down to.
I did try this though. I had it like I had the scaffolding to do a screenshot thing that was based on like take the thing, run it locally, go to the thing, take a screenshot, take a dump of the DOM, look at it, and then loop. Totally didn't work. Like it was so confused.
Yeah,
it was
exactly.
It was hallucinating, actually. It'd be like, looks like I added the button, and I look at the screenshot and there's no button. I'm like, what is this? Like, yeah.
Yeah. I mean, it doesn't work with humans.
Well, okay. Right. Maybe what I'll do is I'll take a screenshot and a dump of the DOM, and I'll do a pixel diff. So I'll be like, your change caused this set of pixels to change to prevent it from being able to hallucinate to thinking that it had implemented the thing correctly.
It's doomed,
and it was just, I don't know, it was a huge mess. I think it's possible. Yeah.
It needs a fundamental update to the way these vision models work. The vision models seem surprisingly competent. Sometimes, like they can always, like you give them a big screenshot with a bunch of text and they like give you an analysis of what the text means. And I'm like, holy shit, like you read all of that for like 80 tokens. Like I don't even, that's more than 80 tokens on the screen in the screenshot. Like what? But then sometimes they're just really, really bad at visual tasks, like horrendously bad. Okay, well, I think we could probably talk about multi-agent for the full hour, but I had one topic that I wanted to ask you guys about, which touches on some things we've talked about in the past, like evals. but it's a little bit more specific, which is when you already have a model that's solving a task well in production, and then a new model comes out that, you know, you've vibed it and it seems better and you decide to swap it in. And then like it does do better in many ways, but there's specific things that it's failing at, whether it's like the formatting. That was a recent case we had where like this model was like way better at giving good answers, like, but it would just get the formatting wrong like 8% of the time versus like 0.1% from the other model that was worse answers. And it was just so frustrating. I was like, why don't you? And I tried adding like formatting instructions that were even more like, you will be punished if you don't do this format. And it would just still just, I was like, God damn it. So it's just like this spiky intelligence thing. But yeah, like more generally, how do you guys decide when to actually push a new model? And how much like prompt changes are involved with that versus like just swapping out the model string? Yeah.
Yeah, we hit this as well. This is definitely a problem because they'll have updates that look innocuous, but sometimes you, especially with formatting, you have to like give it a new directive to replicate the old behavior. And so by definition, you know, or like basically all your prompts need to be updated in that case, right? If you're like,
Right.
oh, format this as a table or as a markdown or whatever.
Right. Is
So
there a
yeah,
solution or you just agree it's a problem?
no, I agree. I mean, let me someone else speak up if you figure this out.
But I've run into this. The only thing that I've tried like recently is to like in the eval tests, try to like categorize the failures, and so you start to see like, okay, you know, the failures are all formatting issues, but the, I don't know, the reasoning or whatever it is, the is better quality. Um, and then, you know, I think it's like zeroing in on like that one problem of, okay, for the formatting, is it like prompt changes? And it's like, okay, no, it's, we can't get there with that. And then it's almost like, do you introduce new tools or like you know, just a model at the end that takes that bad formatted output and corrects it, kind of a thing. Yeah, I certainly seen it. I don't think my solution is is, is like super helpful, but yeah, I think it's just a problem now that uh, these newer models are like, they excel in certain areas, but they lack in others. And so they do take like pretty heavy like rigorous testing and stuff. So yeah.
Are you guys really all still having formatting problems? Because I agree with the kind of jagged frontiers and the surprising trade-offs, but I haven't had a formatting problem for an LLM in like 6 months. Like, are you guys using like cheap open source ones, and I'm still working on the frontier ones, like the really expensive, slow ones?
Hey man, what are you
What kind
trying
of
to
format?
say? What are you trying to say? No,
I'm
I
trying to
think
say
that
you achieve more scale than me, which is why you need to use smaller LLMs. Yeah.
no, I mean, I'm using I'll be more specific on the model I'm using that was really bad at formatting was Kimi K2, which is open source. It is one of the Chinese open source models, but it is a beefy guy. Like it is big. It's like 16 mixture. It's 16 experts, and like I think overall it has like a trillion parameters with like a couple. I think it's like 60 billion active parameters. So it's not a small model by any stretch. I do think that the Chinese open source models are less fine tuned on formatting. I think that could be part of the root cause here. But they're also exceptionally good at other things. Like this model, Kimi K2, is actually by far the best at very specific tasks we have around like emotional understanding, basically like figuring out how someone is feeling based on very subtle cues. There's a good benchmark for this called EQ Bench that we've been looking at, but we also have our own evals along those lines. And Kimi K2 is not only number one on eval on EQ Bench, but it also in our test is really good at those emotional tasks, but it just won't format it, right? It just like doesn't do the thing you want. And it's so annoying because I literally did it where I did the same prompt like 100 times and it would just get it wrong like 6 of them. I'm just like, why? Like, why would you do that? So, yeah, is this just kind of an unsolved thing? And it's like, we just need to be aware of it and wrap those models with like maybe more like explicit code. Because that was the solution I ended up doing, because I didn't want to lose the intelligence. I just wrapped it in like basically formatting code. What I did is I looked in the database and I found every failure to format, and then I categorized them into like, okay, there's 4 different ways it fails, and then I just like handled them. So it's like really brittle, shitty code, but like it worked. I haven't had an issue. So yeah.
It's
Well,
sort
last
of
time
the
I dealt
like,
with this a lot in production, it was actually more insidious than this, where it was very happy to follow the formatting instructions, but potentially at a quality hit. Where if it
Interesting.
was outputting valid JSON, it was just less intelligent in a way that was very hard to measure. And so we actually still have an open project for this, which is, I forget the name of the project, but it's something like Let Them Be Free. Like let the models just respond in whatever format they want, plain text, markdown, doesn't matter, just let it go. And then, yeah, exactly as you said, Chris, like take the smaller model and say, here's some output, please put it in this format. And that
Yeah.
if that's the only task, it'll always work. But it's a lot
That's a
slower.
better
And if you
solution.
yeah, but you also, if you leave it under constraint, it can be really long. And if you there might be some fundamental trade-offs, just in a way where if I give a human, I'm like, hey, human psychiatrist, like tell me what this person is thinking, but fill it out in this specific form with these fields. Versus if you just ask them the question, it might just give you a better answer, because something about being constrained to a certain output or certain schema can actually just interfere with its ability to give you the answer that it wants to give. Yeah, no solution to this. Just like something we've noticed, something that shows up in our evals occasionally. I'm not really sure what to do about it.
yeah, we definitely have seen that too. The like if you're like, please respond in structured JSON, then it just is the contents are not nearly as good. And also Tyler, we did the same thing. It's just there'll be some like post-processing steps to like clear up some of the format things. So yeah, it's brittle, it's like regex, or it's some sort of other, just code that's not robust, but it's good enough for now. I'm waiting for someone to come up with like with databases, there's like database migrations. So maybe one day there'll be like prompt migrations and they'll just fix your prompts or like fix your outputs. But I think as well, I mean, you guys are sort of all talking around the same thing, right? It's like these LLMs are pretty good at qualitative outputs. And when you need them to do a very specific thing in a specific way, uh, it doesn't always do it, or you lose out on the qualitative quality. So yeah, I don't know. There's a great answer there. Like maybe we just need to let it go. What was it, Dan? Like just let them run free, and then and then write really good parsers afterwards or something.
Yeah, I wonder how this works in coding agents as well, because I feel like people have different understandings of the quality of an LLM as a coder based on what scaffolding it's in. And I wonder how much of this is based on the scaffolding, like letting the model be really good at coding versus not. I don't know how Claude Code is implemented or what's going on in that cursor agent or how Codex works, but it's really good at producing stuff in formats that are, for example, like a diff on a file, like it's like the native output of these things. But maybe doing that better or worse, like significantly changes the quality of the code that is coming out of it in a way where like, oh, GPT-5 is so great when I post stuff into ChatGPT, but like Codex is not as good. Or like Claude Sonnet, like it's pretty good, but Claude Code is amazing because somehow it's just getting qualitatively higher quality stuff out of it, or maybe just interfering with it less, or some tricky business like that. But I don't think you can't isolate an LLM. You can't ask how good is this LLM at coding, because coding is now always done with scaffolding. And so now it's, well, how is this LLM scaffolding pair at coding? You can't isolate them anymore.
Yeah,
Yeah, I think
it's
that's
like
exactly right.
the model and the context the model is wrapped in, or the scaffolding, are like so interrelated, which is kind of, oh, we lost Chris. That is the point, is kind of what I'm making, is like, how do you pair that fact, it's like a fact of life, with the fact that you also want to be running through the intelligence that's like spectrum as it advances. You want to be at the frontier. So like as this new model comes out that's like really good at EQ bench for us, like we want that, but then it has these other downsides because we built the system probably not nearly to the degree of complexity as like a Claude Code, but like, yeah, the scaffolding and the model were like making all these assumptions that are in some cases quite subtle in some cases pretty clear. But either way, there's all these assumptions about like that relationship. It's like the yin and the yang, they're tightly coupled, and then you swap it out and it breaks certain assumptions, whether it's formatting or potentially other things. That's a hard problem because you want to be able to keep advancing, because what's the solution? It's just like I'm stuck with either this vendor, so it's like I'm always on Claude no matter what, because I know that Claude did their fine tune in a certain way. That's kind of annoying. Or it's just like I can't change anything. I'm stuck with like Claude 3.7 even. It's like even worse, right? Yeah, it's a tricky one.
Yeah, I would kind of guess that the right approach is to be on either extreme. So either don't put any effort into your scaffolding, or it's just like the kind of spaghetti code of like, well, on this model, there's 4 different parsing errors, so I'll just write 4 different checks and fix them manually, and I'll just do a bunch of stuff that I basically plan to throw away when the next like major LLM comes out, or if I switch to a different provider entirely. I literally will just throw all of that away and then do it again for the new one and just keep it like extremely loose. Or go in the other extreme and just have really good evals that are evaling your system end to end and are like
Right.
checking all of that stuff, where you have the scaffolding that's like looking for formatting errors and raising alerts, and you've got dashboards of latency and all of these things. And like really invest in the infrastructure to make it easier to make that switch later, where you have like observability all throughout your stack. So either go all in or just give up and then just expect to re-engineer each time you do it. I feel like the problem is when you're in the middle. Like you have some tools and some scaffolding and you kind of want it to work, but you don't really know if it's working. Then you're just kind of in this really nebulous space.
That is a really good insight about being in the middle. I agree. I feel like I'm in the middle right now, partly for bandwidth reasons, but partly just because we're moving fast and haven't invested in the observability side. But our system is important, and so we want to be more like the latter case, where it's like highly strict and doesn't make mistakes. So that's definitely the side of like that dumbbell curve that we're picking, but we just haven't actually gotten to that point yet. So I think that is a really nice way to state the core issue there. Okay, cool. So I'd asked kind of like if anyone had in the past month surprising results that they saw. I'll go first. So there was this Anthropic paper that came out last week that at one level wasn't super shocking to me, but at another level was pretty cool, which is that they basically, it's called emergent introspective awareness in large language models. So what they did is they basically injected or like upranked specific like directions in like the latent space, which they, because of their incredible mechanistic interpretability work at Anthropic, where they've actually figured out and mapped like specific directions in that space, referring to different concepts, like, you know, a steering wheel or something like that is like a direction in the space that they can always, it always knows the steering wheel. The example they had was the Golden Gate Bridge, and they were able to uprank that. So what they did is they basically took that ability and they used it to assess whether the models were able to introspect or not by basically upranking in a fake way certain concepts that had nothing to do with the actual prompt, or that would not have been triggered in a normal scenario for that prompt. And then they asked the models to introspect and basically say, like, how did you come up with your answer? And in many cases, they said it was a little bit unrigorous, or that it didn't always work well. But in many cases, the model was able to be like recognizing that this concept like was exogenous and being like, this doesn't make sense. I don't know why that was there, or like stuff like that, where it basically had self-awareness about the fact that they were messing with it, which gave them more confidence that like this model is actually able to understand, genuinely understand, like the underlying reasons why it answered the way it did, rather than just assuming that that is always just pure bullshit, essentially. So I found that quite fascinating, because I could see that being a capability that leads to greater intelligence, right? If it's able to introspect, then you can ask it about hallucinations, and maybe it can just downrank those before you even get it. Or, you know, you could have like a fine-tuning regime that or post-training regime that does something like that. That's just one example, but there's a lot of interesting implications of the fact that the model is at least a somewhat reliable self-critic.
Yeah, I didn't read the paper. I saw the headlines and some of the chatter. I guess I don't really understand that on the fundamental level because humans are really bad at introspecting, AI therapy, right? Like, we don't know the cause of our behaviors or thoughts or actions. We don't know. I mean, even in empirical studies, like humans confabulate. So, like, you trick someone into thinking something for some reason, like you give them some clue and then you ask them, why did you think this? And they will make up any reason other than the thing that you literally just prompted them with. And yet, this is not really a blocker to human rationality. Like the smartest humans who have done the best work, humans still have these problems endemically and are totally unreliable at like every single stage of deduction that you ever do for anything. But maybe because of Dwarkesh's continual learning, or just because of patience, or the ability to take notes, or work in teams, or some other things that humans have, or just more flexibility, or just learning, just the ability to learn without needing to be retrained and be born again from scratch. We're able to invent, new science and nukes and the internet and all of these things. And
Mhm.
so, like, isn't introspection even important? Like, introspection is very important from a safety and alignment perspective. Like, introspection matters a lot if you want to get your hallucinations down, or you want to trust the results, or you want to be able to see if something is right. Like, if I hired a human, I want to be able to ask them, like, why did you do this? And have them be able to answer that as best as possible. It's like, it's useful. But in terms of accelerating intelligence, like, is von Neumann good at, game theory because he can understand his own thought process? Like, is that really important for the intelligence explosion? I'm glad Anthropic is doing it from safety and alignment, but for the takeoff, like, it's taking something humans are really bad at, and then I guess it's more like anthropomorphizing, right? It's human like. I'm not really sure what the thesis is behind it, basically.
That's a good take. I would say you could be right that it's a side quest or that it's only for alignment purposes. I would say alignment is important in the sense that it'll give us more confidence, even at like a regulatory level, potentially, that we are able to use these systems in more places, like being a therapist, right? I think that is a case where a lot of people are like, that's dangerous. You shouldn't do that. There's hundreds of others, right? But being able to introspect gives people potentially more confidence that the systems can be deployed in novel places that maybe have some risk associated with them. And if that's the case, then you'll be able to capture more data and push the boundaries of what's possible. So that would be part of the intelligence explosion, I think, is being able to go into areas where there's more risk involved. So that would be alignment and intelligence are not necessarily at odds with one another. I would say, though, that because they are like systems, I mean, they're a bunch of floating point numbers ultimately, like in matrix math, like the fact that they're better at introspecting could actually allow us to build a loop that a human doesn't really have. I mean, maybe there's some like very slow version of this at evolutionary level where better introspectors could like avoid bad behaviors or something, but that probably doesn't increase genetic fitness very much. Whereas with this, you could imagine like a really good introspection model is able to then be reinforced in a much faster loop about what was like a bad use of mental resources, or like don't think about this in this context because it's not useful, because they're able to actually introspect and basically use that model itself to actually make that feedback loop faster. I could imagine that. I don't think that was like their goal. It wasn't a capabilities paper, but it did make me think that there could be some capabilities there.
Yeah, I think my take is this is pretty big news. I think that introspection is really important because, well, as Dan, you were kind of saying, it's our brains are pretty bad, but the problem is it's like turtles all the way down, right? It's not like it's bad at one thing; it's bad at pretty much everything. And so when you have an intelligence, like, well, we'll just call it generally, you have some sort of intelligence. It doesn't have a body, right? You can't really predict, what can it do? Is it fast? Can it jump? Right? Like, it's viscerally hard to trust, right? You don't just, it's just like, it's spitting out answers, right? And so I think it's like hard for us to trust results from something, especially with something very sensitive like AI therapy, when you just have like very hard time trusting it, right? I think at a subconscious level. And so this introspection, you know, is probably not enough, right? It probably needs to do a lot more, but I think it's a step in the right direction where we can trust intelligences that don't look like us, that don't have our shape. Um, so I think it's good news. I mean, I think that's it's a cool development, especially with like where we are in the hype cycle with AI, where, you know, that initial enthusiasm has faded a little bit. And now it's like, okay, what's next? Now it's like, can you actually trust these AI agents or whatever it is, you know, AI systems to like make decisions for you? And that, like, I think when Tyler was describing that paper, I was like, okay, well, maybe this will push people. There's something here that's like, it's a little bit less of a black box.
Yeah, I guess I'm all for I think I'm the doomer in the group, so I'm all for alignment. I love alignment research and progress there. But I think I'm still going to push back on this, like that the knowing what's going on is that important. You know, if you have, okay, so one example where it's really important is say like some sort of co-pilot system in a plane. Like every line of code that is running in a system like that has like 4 different redundant versions and all of these metrics. Everything is diagnosed, and there's like systems engineers there that do this like ridiculously elaborate fault tolerance and understand everything. Or for like bank transactions that are written in COBOL or something. Like there are people there that will get to the bottom of absolutely everything and can explain every single detail down to the level of like, well, it was a cosmic ray that flipped a bit. Like you'll figure that out eventually. It's like it's somebody's plane or pacemaker or dollars in their bank account. But the world is full of software that is totally uninterpretable even to the engineers that work on it. You try to understand like why Amazon is recommending a product to you or why you're getting a Google search result or something like that. Like the engineers of those companies could never figure it out. They never ever get to the bottom of it, even if you gave them a year. Like the software, even deterministic non-LLM based software, even without even machine learning in it, like machine learning, I think is like the main source of black boxes. But like the sprawling complexity, like nobody needs to understand why Amazon is doing what it's doing, like why it's showing you what product for what price or what reviews it's showing. Nobody even wonders whether it's even possible to answer that question. If it's useful, it's useful, and if it's not useful, like it's Amazon's problem. Like if their reviews are bad or their pricing is unoptimal or their recommendations are bad, then somebody's going to get an OKR to improve some metrics. So like it's important for the sense of can engineers make progress? Can they make a competitive product? But like interpretability is like an implementation detail. Like you can have it or not have it. It doesn't really matter. It's not fundamental to the nature of it. If people are already in the world where you type something into Google and it might get it or it might not, and there's just no possible way of knowing, how different is it to have an LLM? Like Google now has the LLM generated results at the top, and everyone's like, oh, I don't want to get that. I just want the search results. Where are those search results coming from? There's been a transformer in the search ranking for like 5 years. You have no idea what is causing that stuff to be there in the first place. Like LLMs have this additional spooky, mysterious, I don't trust it thing, which is good. It is spooky, it is mysterious, and we shouldn't trust it. That's a good reaction to have. But like we're already well down this path. Like who can explain where any of the things that our software systems are producing, or your self-driving car, you're like your auto following the car in front of you, and like who can explain any of the decisions that's coming out of that stuff? Like nobody can, and we just kind of live with it and move on.
I don't think Dan's going to get hired for the Anthropic interpretability team anytime soon. That is a bad speech to join that team.
But I think he raises a valid point, right? Like you've seen the Waymo videos where they show the like visual overlay of like what it's classifying object set, and sometimes it sees a pedestrian and classifies them as like other, it just runs them over. It's pretty sad. It's pretty gruesome, but. Like I think that is like there is like maybe we can do better. I don't know, but I think you make a good point, Dan. There is a level of inherent trust in these very complex systems that I think you either trust it or you don't, and it's like I don't know. Is it seeing another bar chart or whatever, like a confidence score? Is that really going to get you over the edge? It's not really clear.
For me, it's like it maybe just another tool within the reasoning models, to say that it's introspecting and using that within the reasoning. But I also, I don't know, I guess like to Dan's point, if it only does it some of the time, is it like hallucinating I don't know, it just sounds a little strange. And it's super hard to measure of like how much that's affecting or could affect reasoning. And yeah.
Chris, are you saying it might be hallucinating while it's hallucinating?
Right, exactly.
Yeah. I mean, that was basically the beginning of the paper said that. It was like, it's highly unreliable. And that's why the methodology leveraged like a good research group, they used the earlier results they had about the ability to uprank specific concepts as the way to get around that problem you're saying, Chris. Or maybe I'm not quite understanding what you're saying, but that was like the first thing they said. They're like, we can't just ask the model what it thinks and believe it. Like that's not reliable at all, or it's circular at least. And then therefore they like gave it these exogenous concepts that were definitely not going to be triggered, and it was able to correctly identify its actual path of reasoning versus the injected one, if that makes sense. So it's basically like they gave it hallucinations, and then it was able to figure out which things actually were used, I guess. But yeah. Anyways, I guess last topic is, yeah, do you guys have any other little interesting updates or things that you saw this month that that surprised you or impacted how you're gonna build your products? A tweet, maybe.
I guess I'm
Yeah.
thinking about trustworthiness still, but I was moved by the Claude for Microsoft Excel. I guess
Oh, I
on
didn't
the
see
kind of
that.
journey of AI automating all of our white collar jobs, we engineers are always paying attention to how good coding is, right? We care about that. And then there's this kind of weird moats of defensibility. Yeah, I think Michael, you can speak to this well about places where it's not really the work being done, but like the constraints or the legibility, the accountability, the ability, to cover your ass, like, and many other reasons why white collar work won't fall to LLMs, even when intellectually it probably did a year ago. And to see Claude go into Excel, a place where you really are not supposed to hallucinate and get things wrong. Of course, humans in Excel do all the time, but like kind of the whole point is that you are supposed to kind of work it out and get it right. To me, it was, yeah, I don't know, maybe I'm harping on the previous topic, but there's something about trustworthiness I'd like to understand better. I'm claiming that like everything is kind of black boxy, except for a very small number of things in our world. There's no true trustworthiness of like, I'm going to inspect this request and get all the way to the bottom of what caused this to happen. But trust is still a real thing. People do still give trust to certain products or technologies and not to others. What causes that? Like, what is going to lead a person in a business context to trust Claude and Excel versus not trust Claude and Excel? Yeah, like Michael, is it going to be another bar chart? Is it just going to be because Anthropic is a trustworthy company? Is it like trust but verify? Like you just try it and you inspect it the first half dozen times, and if you don't see any mistakes, then you just kind of let it go. We have a version of this in coding where we're letting our coding agents run rampant through our code. Generally, we at least look at it right before we merge it into main, but not always. And like there's kind of a trust thing going on there as well. So what is it? Like what leads to the trust, and like what types of things is there kind of a very impenetrable moat of trust? Like I'm never going to have an AI be my therapist for some inscrutable reason versus, oh, it just gets like slightly better, or you change the feature set slightly and suddenly people are like, yeah, this is great. I have no problem with this. I'm completely comfortable having an AI be my therapist.
Right. I think it's a great question. Just my quick thought would be there's going to be a competitive process that'll work itself out, and we'll find out what's optimal. Meaning, taking the Excel example, let's say you have 1,000 companies and 10 of them just embrace it wholeheartedly, just full vibe accounting, and then maybe 100 are like using it, but they're more cautious. And then the other 900 are just like, heck no, we're never doing this. And then we'll see, like, where do the market results come? Like, is one of those companies able to just completely save all the money on the accounting budget, and then they just are have higher margins or make better products? Like, and that company will then scale and grow or have better investments. Like, I would say it's going to work out that way. And similarly with other products, like let's say, for example, 1,000 people are considering an AI therapist. 500 of them are like, definitely not. That's black magic, for sure, never doing that. And then another couple hundred are like, yeah, I'll definitely try it. And then, you have 100 superpower users. And then like, we'll find out, like, are those 100 superpower users like actually having like better emotional lives? Are they actually building better relationships? Are they building more like sense of fulfillment in their life? Like, and then that will filter out, and they'll, word of mouth, they'll be like, oh yeah, I have been feeling better lately, and here's why. Like, and other people will kind of adopt, and the curve will just kind of move down the line, I would say. Or maybe not. Maybe like the people who talk to the AI therapist have a bad time, and the 500 people who said no will feel vindicated. I think that's generally how trust works. Like it's kind of like a market-driven process at some level.
There's a lot of layers there, Tyler. You introduced a lot of layers.
What do you mean?
I mean, trust. Okay, actually, maybe I'll take a different direction. So at a previous startup, we worked on a very adjacent problem, I'd say. We called it the data last mile problem, where you go from data, with let's say a spreadsheet or bar chart or whatever, and then you want to get value out of it. So this is like, okay, I want to make a presentation to the board, right? Or whatever. I want to make a presentation, justify this growth strategy or something like that, right? So now you go from data, nicely formatted, maybe in a real-time dashboard, maybe with your like Snowflake or whatever else, tons of crazy databases. And then what you actually want is to tell a story, right? A narrative. You're in persuasion land, right? So now you want to do actually a custom graphic in like PowerPoint with your labels and your like misleading axes, right? Or you want to present it in the most favorable way. Turns out like no executives want to actually log into your Snowflake dashboard or whatever. No one wants to like play around with like the different roll-ups, right? So the problem is this jump from data to persuasion, right? Which is like, okay, if you had just wanted the persuasion piece, why did we even do the data piece? We could have just made the decision. It would have been way faster, right? Like basically people are like vibe check plus data. So this is something that's shifted over, let's say, the last 20 years, where it's like, oh, you got to be data driven, right? But then it's like you have all the data and then you just ignore it, or you just like paint the most favorable picture. So then it's like, okay, let's go back to trust. Where does the trust come from, right? So clearly it was not the Excel document.
Right.
And that's what is like Cloud Code, whatever, is very good at generating those. But obviously there's more to the job, as Dan was kind of saying, right? There's something else going on that like that the trust is coming from. And it's not just the, whatever, sales pipeline dot XSLX or whatever.
Yeah. I think we'll close with this. I think it's like a forest fire, and then we're going to find out what's inflammable. And maybe the answer is nothing. Like maybe the answer is like AIs are going to be way better at convincing executives to take a certain path. Or maybe those are kind of inflammable. The human is always, there's a deeply human element to that trust relationship, and it's never going to go away. But we'll find out. I mean, I think it's definitely coming for all of the like process-oriented tasks. Like any task that can be like described in a procedure, no matter how abstract that procedure is, like that I think will go away. But like when it comes to like choosing who to marry, or whether to have kids, or like where to live, or like should you invest in this company or not, like there is no procedure that we have to, even at a high level, to describe that task. And so those are the things that I think will for sure be left to the humans,
Famous last words.
Famous last words. Yeah, we're going to have AI wives in like 2 years. So never mind.
I'm thinking about how to shoot holes in that argument right now. Maybe we'll save it for next time.
Yeah. All right. Good chat, guys. See you next month.
Thank you very much.
Bye.
Bye.